Hello class, today we are going to be working on 7.5 problem solving with Pythagorean theorem, part A, right angle triangle or not. So from yesterday I did mention it, but the Pythagorean theorem will only work with right angle triangles. So we have our left side and our right side of our equal sign, and if they don't match up, then we know that it's not a right angle triangle. Just a refresher to go over as well. We have our two smaller sides, A and B, and this side here is the hypotenuse, or is always the longest side, and that is the C. Okay, so what we're going to do is we're going to look to see if it's a right angle triangle by using the Pythagorean theorem. So if a right angle triangle, Pythagorean theorem will be true. So right side will equal left side. So we need to break our question down to left side and right side. So we've got a squared plus b squared on the left side, and the right side is c squared. So we have all the information. All we have to do now is plug it in. So a is 5, so we have 5 squared. B is 12, so 12 squared. And c is 13, so we have 13 squared. Right? So we always have to use those squares. So putting them out, 5 squared is 25, 12 squared is 144. We get 169. Now in our calculator, if we did 13 times 13, remember it's not 13 times 2, we get 169, and we see that both sides are equal, so this is indeed a right angle triangle. So you're going to use the same thing as you go through our questions, finding out if it is indeed a right angle triangle. Remember, the C will always be the longest side. So number 1A, we have 16 as our longest side, or maybe 18. I believe it's 18, is a little hard to read. On B, our longest side is 29, so we know that that is our c squared. So it is very important that we remember that. So A and B will be the smaller two numbers, and C will always be the largest number. Another one that I want to show, give an example to, is part B, is solving problems with the Pythagorean theorem. So we're going to look at number 1 together. We're going to solve these and we're going to create a diagram unless there's one given to you. As we see in A, we already have one, but number 2, we don't have one, so we're going to need to draw one in. Then solve the problem, showing all your work, round to one decimal place when necessary. All right, so our gate is strengthened by fixing 2 struts along each of the diagonals. So that's our thick black lines here. The gate is 2 meters long and it is 1.2 meters high. Find the length of each strut. So if we break this down, we can actually see 2 triangles here. So we've got a diagonal line there, our bottom line and our top line, and we know that this top line will also equal 2 meters, and going down will also equal 1.2 meters, and then again we have this strut here. So that's what we're looking for, is these 2 dark black lines. They are matched up with triangles on either side. So they're going to be the same because we have a rectangle that are the same. So once we find one, we know that both of them are the same. So a squared plus b squared equals c squared. So a squared plus b squared will equal our c squared. So 1.2 meters squared plus 2 meters squared will give us c squared. So 1.2 squared will give us 1.44 plus 2 squared, which is 4. So we have 5.44, and we need to take the square root. So that's to get rid of this little 2. So again, we're just cutting it off from being a whole square. We're cutting it down to just the one side from that. So we need to do the square root of 5.44, and C will then equal 2.3 meters long. So therefore, the strut is 2.3 meters long. So that's what we need to do in order to secure our gate, or strengthen our gate rather. So number 2, I just want to show you real quick in terms of what the question is asking and how we have to go about it. So we see that Tara leaned a 17-foot ladder against the house. The bottom of the ladder is 8 feet from the house. How high up on the side of the house is that ladder, the top of the ladder? So first off, let's draw our house. So I'm just going to draw a straight line right there. And what we want to know is, we said that she told us that it is 8 feet away from the house. So I'm just going to draw another line. This is our 8 there. And now that's the edge of the ladder. So now we have put our ladder up here, and it's going to go up against our house. Hopefully your lines are a little bit straighter than mine. And we know that this right here is 17. And that's 17 feet. So now we need to find out this, which is our A. Okay, so now we can go into our question knowing a squared plus b squared equals c squared. We have two of them. So we're going to need to do some flip-flopping around to get b to the other side so that we have a on its own. So going from there and solving it algebraically until we get to finding out what a equals. All right, so your task is now to complete the following questions as well as the rest of them from part 1.